Okay, so you missed the lesson on decomposition and combination reactions. These are 2 of the 5 types of chemical reactions. And we've actually already seen an example of each of those reactions in lesson 4.1.2 and then in 4.1.3. So let's take a look at their definitions and see if we can figure out what we classify the reactions we've already seen as. So it says, first, we've been looking at 2 types of chemical reactions. When one substance is broken down during a chemical change to form 2 or more substances, it is called decomposition. When a single substance is formed by combining 2 or more substances, it's called combination or synthesis reaction. And this should be review because we've already mentioned the terms reactants. That's what you start with in a chemical reaction, and they're to the left side of the arrow. And what you end up with, the new substances, are called the products, and they're on the right side of the arrow. So if we were to write a simple version of each of these reactions, decomposition would be a compound that breaks down, and combination would be 2 things adding together to become one. So in class, when we did lesson 4.1.2, we saw water decomposing into hydrogen and oxygen gas. And you might notice that there's 1 atom here and there's 2 there. So this reaction is breaking the conservation of matter. But what we're going to find out is we're going to be able to do something called balancing a reaction in lesson 4.2.3 is when we first start talking about that. So that's coming up. So don't worry about that too much right now. The combination reaction that we saw was when we made our propeller go in lesson 4.1.3. We took hydrogen gas and oxygen gas, and we were making water vapor in the fuel cell. Again, you're going to start seeing what's called a coefficient out in front, and if there's nothing written, that just means there's 1 of the molecule there. Also something new, there are these molecules called diatomic molecules, and what that means is if they're alone, they're never actually alone. They find another single atom of their same type and combine. So for example, a hydrogen and another hydrogen makes H2. That's why you never see just an H written by itself. Oxygen does the same thing. It makes a double bond. Fluorine and another fluorine. Bromine and another bromine. Those are in group 7A, so they have 7 valence electrons and can form 1 bond. Same with iodine. Nitrogen, we've seen, forms a triple bond. And chlorine, last but not least, 2 chlorines together. So there's some fun ways to remember these 7, and that's important because you do have to know those. One of them is that they spell just a funny made-up word, Hofbrinkel. And I recommend practicing actually writing the elements as you say it, because you think, oh, Hofbrinkel, I've got it, but then you try and write the elements and it's like, wait, what? So practicing is good. Another one some people like is Brother Han Cliff. So again, that's bromine, hydrogen, oxygen, nitrogen, chlorine, iodine, and fluorine. And then there's one more, a sentence. I brought clay for our new home. So you have to remember that 2 of the words have 2 letters to start. Okay, so in this activity, what you're supposed to do is first classify each of these reactions as combination, which can be compared to a marriage, and decomposition, which can be compared to a divorce between the molecules. And you can also think of it as something decomposing. So take a second, pause the video, and go ahead and label each of these with a C or a D to show that you know what each of those types of reactions is. And then Oh, actually it tells you to highlight one in one color and highlight the decomposition in another color. And then there's some other things that you're supposed to do too. So take a few minutes and actually go all the way through questions 1, 2, and 3. All right, let's check out these answers here. So let's figure out a color to highlight the combination reactions in first. So combination, again, you'll look for a plus sign on the left of the arrow and one product on the right side. So there's a combination, another combination, 3 combinations, 4 combinations. Decomposition, we're going to look for one thing, then an arrow breaking down, and the plus sign will be on the right of the arrow. So all of these are decomposition reactions. Then it says, go ahead and circle the molecular substances that contain covalent bonds. So we're looking for things that have all nonmetals. So all of these that I'm circling have no nonmetals. So most of these are covalent bonds. Potassium's a metal, so we can't circle that. Covalent, 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 covalent. Technically, a couple of these are ions, but I'm not sure if I'm supposed to circle those. So we will. All right, then it says underline the ionic solids. Choose a different color. Na2O, oops, Na2CO3, KClO4, KCl, Mg3N2, Al2O3. What form are individual ions found in? Gas, liquid, solid, or aqueous? And I've already pointed out these ions here, and they are found in the aqueous form, which means they're dissolved in water. 2 and 3 we kind of already did. It says write an equation that represents your understanding of the decomposition of water to make hydrogen and oxygen gas. And we can be a little bit better now because we can label liquid and gas. And then vice versa, what about the combination reaction? We take hydrogen gas and oxygen gas and we make water. Then it wants you to watch the computer simulation for the fuel cell so that you can see kind of what's going on there. And I do recommend doing that. So take a couple minutes and watch the simulation so you can see how the atoms were breaking apart and forming new bonds. Name at least 3 compounds other than water. What would the products be of those compounds breaking apart into elements that make them up? So you can choose anything. So something that may come to your mind would be NaCl. And if that breaks up, it would form Na and Cl2. Again, because that's one of the elements that's in Hofbrinkel. So that would be a compound that could break apart. You might say CO2 breaking up into carbon and oxygen. Again, oxygen getting a 2 because it's one of those 7 diatomic elements. And then another thing that you might think of breaking apart, let's see, I'm just going to pick a random one, magnesium oxide. Breaking apart would form magnesium and O2, since, again, that's a diatomic element. Something that's new is revisiting the idea of crisscross when you're writing a product. So, for example, when aluminum and oxygen form an ionic compound here, we have to crisscross their charges. So this would form Al2O3, and since this is ionic salts are solids. And since this is two things adding together to become one, this would be a combination reaction. Water breaking down, we've seen this several times, forms hydrogen gas and oxygen gas. So this would be a decomposition. A big hint was that it was one molecule and then just an arrow. Na and Cl2, since this is a new relationship, you have to check the charges, and we do not need that 2 anymore next to the chlorine. So it's just NaCl. Again, because it's an ionic compound, we can assume that that's a solid. And that is two things coming together, so that would be combination. AgCl breaking apart would form Ag and Cl2. Again, because that's in Hofbrinkel. And silver is a metal, so that would be solid. And chlorine, if you look at the periodic table, is red because that would be a gas. One thing breaking down makes a decomposition reaction. Oh, this was one of the examples I chose. Again, magnesium's a metal, so it would be a solid. And oxygen we know is a gas, and that would be another decomposition reaction. Magnesium's got a +2 charge, nitrogen's got a -3. So when these two form a new compound and we crisscross, we make Mg3N2, and that should get a solid, since again this is an ionic compound, and that's a combination reaction. KCl breaking apart would form potassium, which is a metal, and chlorine gets a 2 because it's one of the 7 diatomic elements, and a G for gas. So that would be another decomposition. And last but not least, barium combining with fluorine would form BaF2. Since that's an ionic compound, we can assume that that is a solid, and that we would write a C for a combination reaction. So that's what you missed in lesson 4.1.4.